Today in this video I am going to discuss about the solutions of few problems related to central orbit. So let us start with the problems. Here you can see I have selected the exercise from Dattojana. I am going to start with the solution of question number 15. So let me write the question first. Here it is given. In question number 15, the velocity at any point of a central orbit is 1 by nth of what it would be for a circular orbit. At the same distance. That means directly velocity of projection is not given to you. Then show that the central force varies as 1 by r to the power 2n square plus 1 and the equation of the orbit is r to the power n square minus 1, that is equals to a to the power n square minus 1 into cos of n square minus 1 theta. So the first important point is what? Here the velocity at any point is 1 by nth of what it would be for a circular orbit at the same distance. That means you need to use the concept of velocity in a circular orbit. And then obviously we need to prove two different things. One, the criteria for the central force, or better to say the law of force, and then you need to prove it that the final equation of the orbit will be like this: r to the power n square minus 1 is equals to a to the power n square minus 1 cos of n square minus 1 into theta. So this is our objective. So let us start the solution. Initially you can consider that let r comma theta be the position of the particle at any instant t. Let v1 be the velocity of the particle at any point of a circular orbit. Say under the central force, capital F. Then we have mv1 square by r. This is the net force acting on a circular orbit, will be equal to F. M is the mass of the particle. I hope all of you can remember this criteria. Already we have discussed in our classes, and then from here you can say it will be equal to v1 square by r, that should be equal to what? F by m. So this is one possible condition. So if we assume m is the mass of the particle, then directly we have used the criteria mv square by r, that should be equal to what? F, and from here v1 square by r should be equals to F by m. Obviously you can find out v1, which is nothing but root over fr by m. So this is first equation. We have to utilize it. Now let the velocity of the particle at the point r theta, because you have initially chosen the position of the particle is nothing but r comma theta. So we can say velocity of the particle at the point r theta is small v. Then according to the problem, remember 1 by nth of what it would be for a circular orbit. So v can be written as 1 by n of v1. That means v square will be v1 square by n square. Already v1 square is what? Fr by m. So Fr by n square into m. And so you can say that small v square will be equal to what? F by n square mu, where u is equals to 1 by r. Again we have v square is equals to what? H square within bracket du d theta whole square plus u square. This is again another standard relation, I hope we can remember. So v square is equal to right now f by n square mu. So f by n square mu, that is equals to h square multiplied by du d theta whole square plus u square. So it simply implies du d theta whole square plus u square, that will be f by h square n square mu, which ultimately shows that f by h square n square mu, and from here you can see what? This entire structure f by m can be considered as what? Can be considered as a new quantity, so that you can imagine this is of the form p by h square n square then u. I hope up to this all of you have understood the problem. So this is say equation number 1. Now we have the differential equation of the central orbit or of a central orbit is d2u d theta 2 plus u by p by h square u square. We know this thing, say this is equation number 2. Now you can find out the solution by first multiplying this entire expression by 2 du d theta, and then you can proceed. Now there is another way, let me show you that one. Let us divide this equation 2 by equation 1. Dividing 2 by 1, we get this divided by this. So d2u d theta 2 plus u divided by du d theta whole square plus u square. d2u d theta 2 plus u divided by du d theta whole square plus u square. On the right hand side, this divided by this, you can see this divided by this. So pp will be cancelled, h square will be cancelled, then you will get n square by u. So right hand side will be n square by u. So this is equation number 3. Now multiplying both sides by 2, and then let us try to integrate this expression. So 2 d2u d theta 2 plus u du d theta whole square plus u square, that should be equal to 2, under the sign of integration we have this type of structure. So this is equation number 4. Now let du d theta whole square plus u square equals to some quantity c, then 2 du d theta d2u d theta 2, then 2u du d theta, that will be equivalent to dc d theta. So 2 d2u d theta 2 plus u will be equal to what? Will be equal to du will be equal to dc. So from 4 we get, now you need to substitute this result in equation number 4. Then this expression will be what? This expression will be dc divided by c, and on the right hand side 2 n square by u du. Obviously you have integrated, so you can consider some constant c1. So log c after integration 2n square log u, and for convenience I have taken this c1 is equals to log a new constant, and that means you can say log of, as per our substitution, c is what? C is equivalent to du d theta whole square plus u square. So as per our substitution we can write it is equivalent to log of du d theta whole square plus u square, on the right hand side 2n square log u plus log a. Say this is equation number 5. Now here it is not mentioned what we need to do. Actually we are going to consider the particle is projected from an apse. That will be better for us to get the initial conditions. So for an apse du d theta should be 0, u should be 1 by a. So from 5 we get this part will be 0, this part will give you log of 1 by a square, then on the right hand side 2n square log of 1 by a plus capital log of capital A. Then we need to find out capital A. So log of a will be what? Log of 1 by a square minus 2n square log of 1 by a. So log of a will be log of a to the power 2n square minus 2. You can consider this one as a to the power minus 2, this part as a inverse, so adjusting this will give you a to the power 2n square, and this from here you will get minus 2. So log of a to the power 2n square minus 2. I repeat, this is log of a inverse. Then using the property of logarithm, this will give you log of a inverse whole to the power minus 2n square, so it will give you a to the power 2n square, and this part can be written as what? A to the power minus 2. Adjusting you will get log of a to the power 2n square minus 2. So a should be equal to a to the power 2n square minus 2. So we have obtained this result. Now we need to proceed further. Now from equation 5 we get log of this entire expression du d theta whole square plus u square. That will be equivalent to log of u, from here you can see u to the power 2n square, and then log of a to the power 2n square minus 2. So you can write this part should be equal to u to the power 2n square, then a to the power 2n square minus 2. This is a to the power 2n square minus 2. Say this is equation number 6. Now we need to consider the first equation. Say this is the first equation. Here we have used du d theta whole square plus u square. This is equal to this expression. So p by h square n square u. Remember what was p? h square n square u. So F by m, force per unit mass, that has been considered as P. I repeat, force per unit mass will be considered as P. So here we can write P by h square n square u will be equal to this expression, and this expression by 6 is equal to this. So using 6 in 1, we get P by h square n square u, that is equals to u to the power 2n square, then a to the power 2n square minus 2. Now from here you can easily find out the expression for P. Just multiply this expression. So P will be h square n square u to the power 2n square multiplied by u. So u to the power 2n square plus 1, a to the power 2n square minus 2. So n square, h square, u to the power 2n square plus 1, a to the power 2n square minus 2. So P can be rewritten as a to the power 2n square minus 2 multiplied by n square h square divided by r to the power 2n square plus 1, since u is equals to 1 by r. Now you can see P is what? Force acting per unit mass. So F will be what? MP. Now from this expression, what can you say? This part will give you m into n square h square a to the power 2n square minus 2 by r to the power 2n square plus 1. That is, you can say f, everything is constant in the numerator portion. So f proportional to 1 by r to the power 2n square plus 1. Now remember what we wish to show. The central force varies as 1 by r to the power 2n square plus 1. So F is proportional to this, and F is the central force. M is the mass of the body or the particle, so it is a constant. N, H, A, everything is constant. So you can say this is the required criteria. So you have proved the first part, and here you have to write proving the first part. Okay, now let us proceed towards the second one. Here in the second part we need to find out the equation of the central orbit. That means you need to perform certain integration, and obviously integrating the given structure you will be able to get the equation of the central orbit. Now let us focus on this equation. Equation number 6, this one. So from 6 we can say du d theta whole square, this will be this minus u square. So u to the power 2n square a to the power 2n square minus 2 minus u square, u to the power 2n square a to the power 2n square minus 2 minus u square. Now let us take u square common from this expression, then u to the power 2n square minus 2 a to the power 2n square minus 2 minus 1 u square. You can write in this fashion. So du d theta can be written as plus minus of u multiplied by root over of this expression, that is du can be du d theta in the next line can be adjusted in this way, u into au. Actually you can write in this fashion also, plus minus y u root over au whole to the power 2 n square minus 1 minus 1. In this way we can write this expression, a u then to the power 2n square minus 2, and so you can write au whole square to the power n square minus 1 minus 1. From here you can rewrite this expression in this fashion. So here we are using this criteria: au whole square to the power n square minus 1 minus 1 plus minus d theta. This is equation number 7. Let au n square minus 1 equals to z. So n square minus 1 log of au, that will be log z, operating log from either side, differentiating both sides, you will get a n square minus u log of au. So this one du, and from here dz by z. So du by u will be equal to what? 1 by n square minus 1 dz by z. So let us use this. So from 7 we get 1 by n square minus 1 dz. This portion is what? Z square minus 1. Now obviously you have one more z in front of this expression. On the right hand side you have plus minus d theta. So du by u, this part is equal to this 1 by n square minus 1 dz by z, and that's why dz by z root over z square minus 1. Now you can easily integrate. Then plus minus n square minus 1 d theta. So integrating you will get sec inverse z plus minus some constant should be introduced, n square minus 1 then theta plus b. Say this is equation number 8. Now initially say the particle is at a distance a, for example, that is r equals to a. So let us take u is equals to 1 by a. If we put u is equals to 1 by a, then as per our substitution z should be, from here you can see z should be 1, and theta, next you need to find out the value of theta. So if you put z equals to 1 here, then u is equals to 1 by a, z will be 1. Put z equals to 1, accordingly theta should be equal to 0. So from 8, sec inverse 1 should be equal to 0 plus b. That means b should be equal to 0. So from 8 we get sec inverse z, that is plus minus n square minus 1 theta. So sec of n square minus 1 theta, that is equal to z, which will imply au whole to the power n square minus 1, that means z equals to this, we have already taken this one, is equals to sec of n square minus 1 theta. And from here a by r whole to the power n square minus 1, 1 by cos of n square minus 1 theta. Now as per proof we need to adjust this final relation, r to the power n square minus 1 cross multiplying this expression, a to the power n square minus 1 cos to the cos of n square minus 1 into theta, hence the proof. This is the solution of this problem. So in the first part we have proved the criteria for the force, and in the second part we have obtained the required equation of the central orbit, and this is the solution of question number 15. Now let us discuss about another problem. Let us discuss about question number 16. A particle is acted on by central attractive force mu u cube is projected with a velocity this at an angle 45 degree with its initial distance a from the center of force, and we need to find out its equation of orbit. So we have to show that the orbit is nothing but an equiangular spiral. So here I am writing question number 16. The particle acted on by central attractive force mu u cube is projected with a velocity root over mu by a at an angle 45 degree with its initial distance a from the center of force. Show that its orbit is the equiangular spiral r is equals to a to the power minus theta. Forget about equiangular spiral, simply focus on the fact you need to find out the equation of the orbit. That's our main objective. So initial velocity of projection is this. It is projected with an angle 45 degree. Force expression for force is mu u cube. Because 45 degree is mentioned here, so we need to use the criteria p equals to r sine phi, or here it will be p equals to a sine phi. Okay, and then under all these situations we have to consider that the equation of the orbit will be like this. Initial distance is a, already it is given in the question. So suppose this is the initial line, this is the curve, this is the position of the particle. We have drawn the tangent through that position, p equals to r comma theta. You can join it. So this is the radius vector r, this will be theta. You can also create the perpendicular, so this will be denoted by small p, and here this angle can be considered as phi. So this is our initial diagram. So we can say let p r comma theta be the position of the particle at any instant t as shown in the diagram. Now the angle, position of the particle at any instant t. Now the angle between the tangent, here you can see between the tangent and the radius vector, this one, this particular angle, I am talking about this angle between the tangent and the radius vector at p is phi, and the perpendicular distance of the pole, obviously O is the pole, perpendicular distance of the pole from the tangent is P. This one is the perpendicular distance. So P equals to, we know, r sine phi. Now at the time of projection, remember initial distance was supposed to be a, so you can write r equals to a and theta equals to 45 degree. So P equals to a sine 45. So it will be equal to a by root 2. Again we have a criteria h equals to Vp, where v is the velocity of projection and projection of the particle at P. You can write in this fashion: of the particle at P. Coordinate of P is r comma theta. Now at the time of projection it is given v is equals to root mu by a. Time of projection, v is equals to root mu by a, and P, already we have obtained this one, P is equals to a by root 2. So h from here, h will be root mu by a by root 2. So it will be root mu by 2, root mu by 2, root over mu by 2. And v square, remember the criteria, h square du d theta whole square plus this, so v square by h square, that will be du d theta whole square plus u square. H equals to Vp. From this relation you will get what? H equals to Vp means v by h will be 1 by p, so it will be 1 by p square, that is equals to this one. Actually we are using this condition here. Now given that the central attractive force, what is the expression for force? Mu u cube. F is equals to mu u cube, and we have the differential equation of the central orbit is d2u d theta 2 plus u, that is equals to a by h square u square. This is the formal definition we have derived in this equation in our class, so we need to put all these values right now. d2u d theta 2 plus u, no need to change this expression, simply we have to use the expression for f, and you know the value for h also, already we have proved this one. So d2u d theta 2 plus u, what is the value of f? F is mu u cube, h square will be mu by 2 multiplied by u square. So from here you will get mu will be cancelled, 2u. So d2u d theta 2 will be u. So multiplying both sides by 2u du theta, we know this formal technique, and then integrating we get what will be the result? Du d theta whole square. On the right hand side, u square, 2 du d theta, 2 will be cancelled, plus some constant a. So that du d theta whole square plus u square can be rewritten as 2u square plus a. But already we have proved this expression is what? 1 by p square. This one, 1 by p square. So this part can be replaced by 1 by p square. So this is, say, equation number 1. Now again remember, p is equals to what? A by root 2. Now p is equals to a by root 2. You can write initially, and initial distance is supposed to be a. P is equals to 1 by root 2 and initial distance is nothing but a. So you can write u will be 1 by r, that is equals to 1 by a. So utilizing these two results in equation 1, we get 2 by a square plus a, that is equals to what? 2 by a square. So a will be 0. So from 1 by p square, that is equals to 2u square. But remember, p square is nothing but du d theta whole square plus u square. So du d theta whole square will be u square. Now u is equals to 1 by r. So definitely you can write du d theta will be minus 1 by r square. dr d theta, taking the square on both sides, you will get 1 by r to the power 4 dr d theta whole square, that will be equal to 1 by r square. And from here, dr d theta whole square will be what? R square. So dr d theta will be plus minus r. Because the force is attractive, we are choosing the negative sign. So here you have to mention, since the force is attractive, so this will indicate dr by r, d theta, minus d theta in fact. So integrating log r minus theta plus b, say this is equation 2. So initially at r equals to a, if you put r equals to a, angle of projection is 0, initially nothing is mentioned, and so you can write log a should be equal to p. So from 2, now here don't get confused over this fact, projected with a velocity at an angle 45 degree. Just before the beginning of the motion there will be no angle, that's why theta should be considered as 0, and when the particles executes the motion, theta should be 45 degree. That is the main criteria. So from equation 2 we get log r minus theta plus log a, that is log of r by a, that is equals to minus theta, and then you can write r by a, that is equals to e to the power minus theta, and finally you have r equals to a e to the power minus theta, which is an equiangular spiral and the required equation of the orbit, hence the proof. This is the proof of this problem, for problem number 16. So I hope these two problems are clear for all of you. And again I am saying, if you have any doubt regarding any problem from any particular chapter or from any book, you can directly ask me, and obviously you can comment, and obviously some other problems will be given to our WhatsApp group so that you can practice all those problems in a proper way. Thanks for watching.